Hello guys and welcome. We'll start a series of lectures on DHCP security. At the end, you will know how to hack DHCP and what are the countermeasures you can take. Let's take a look at the purpose of DHCP and how it works. This is really necessary in order to deeply understand the attacks on DHCP and how to mitigate the impact. Dynamic Host Configuration Protocol, or DHCP, is used to dynamically provide IP addresses and other configuration information to host on the wired or wireless networks. When you connect your mobile phone or your laptop to the Wi-Fi network, they will receive all necessary information to communicate on the network and on the internet, like IP address, network mask, default gateway, and DNS servers from the DHCP server, which in many cases, especially in small LANs, is the router. The configuration is assigned with a lease time. For the end user, DHCP works behind the scenes. Let's see in a nutshell how it really works. The admin sets up the DHCP server and creates pools of addresses available for assignment to the clients, wired or wireless. When a device is turned on and connected to the network, if it's configured to use DHCP for its network configuration, it will send a request to the server called DHCP Discover. This first message is a broadcast one, and that means that any host on the network will receive it. Maybe there are more DHCP servers, and each server will respond back to the offer. After the Discover packet reaches the DHCP server, the server reserves an IP address for the client and makes a lease offer by sending a DHCP offer message to the client. This package contains an IP address, a subnet mask, a lease duration, and the IP address of the server making the offer. This second message is a unicast packet, so only the requesting client will receive it. In response to the DHCP offer, the client replies with a DHCP request message broadcast to the server requesting the offered address. Why is this a broadcast packet? It's because a client can receive DHCP offers from multiple servers, but it will accept only one DHCP offer. Based on the required server identification option in the request and broadcast messages, servers are informed whose offer the client has accepted. And finally, the server will send a DHCP acknowledgement packet to confirm the configuration to the client. This packet includes the lease duration and any other configuration information that the client might have requested. At this point, the IP address configuration process is completed. If the server decides that the device cannot have the IP address, it will send a negative acknowledgement or an NACK packet. When the client leaves the network, it could send a DHCP release to inform the server that will deactivate its address. The server can offer this IP address to another client. Let's see these DHCP messages in Wireshark. I'm opening Wireshark, and I'm starting the capture on the Wi-Fi interface. It's capturing data. Now I'm connecting my mobile phone to the Wi-Fi network. My mobile phone, like the vast majority of the phones, is configured to automatically set up its network parameters using DHCP. And I'm connecting it to the network. You won't see this, I have the phone in my hand. You are seeing a lot of traffic, but I'm filtering to see only DHCP packets. So I'm applying a display filter, DHCP. Perfect. If it doesn't recognize the DHCP filter option, especially in older versions of Wireshark, you can write boot P as well. So boot P. Boot P or boot protocol is in fact an older version of DHCP, like a legacy DHCP. Both options are working, but I'm writing back DHCP. And we notice the broadcasted discovery message sent by the phone. This was received by any host on the network, including this Windows machine. Then the server responded back with an offer sent to unicast. We can't see the packet on another host, like on this Windows machine, because it's a unicast packet. And in the third step, the phone has requested the offer, sending a broadcast message that we can see in Wireshark. Now that you know in detail how DHCP works, let's go ahead and take a look at the attacks on DHCP. Note that the attacks could happen due to lack of any authentication mechanism between DHCP server and DHCP clients. There are mainly the following types of attacks: DHCP flooding, DHCP starvation, and DHCP rogue server. Let's take them one by one. In a DHCP flooding attack, the hacker will flood the server with fake DHCP discover messages. The server will start processing these messages and become unavailable for legitimate clients that will not receive an IP configuration. This is a denial of service attack. A DHCP starvation attack occurs when an attacker constantly sends fake DHCP requests with spoofed MAC addresses to a DHCP server. Eventually, there are no more IP addresses available to allocate to legitimate devices, and the network becomes unusable. This is also a denial of service attack. DHCPig, DHCP Starve, Gobbler, or Yersinia are tools that can perform these attacks. We'll see them live in the next lectures. And the last attack we are talking about is called DHCP rogue server. A rogue DHCP server is a server set up on the network by an attacker or by an unaware user and is not under the control of the network admin. Using the rogue server, the attacker can start sending IP addresses and other configuration settings to the network DHCP clients. These configuration settings include default gateway and DNS server IP addresses that are not the legitimate ones but are of the attacker or under its control. Once the default gateway IP address of the network devices is changed, the network hosts start sending the traffic destined to outside networks to the attacker's computer. The hacker can now capture sensitive user data and launch a man-in-the-middle attack. This is also called a DHCP spoofing attack. Hackers can also set up a rogue DNS server and deviate the user traffic to fake websites and launch phishing attacks. Okay, in this lecture, we have seen how DHCP works, what are the security problems, and how a hacker could attack DHCP. In the next lectures, I'll show you live examples of these attacks.